Hi everyone, today I am going to refine XRD data using foolproof 64-bit software. I saw in YouTube all videos are without voice. Only programming has been done there. I know that this is very difficult for beginners. That's why I made this video. So here I'll try to make understand you that why are we doing all steps here. So I have a XRD pattern of barium titanate here. This is my BaTiO XRD pattern. But if you check its property, then this is XRD ML file. First, we have to convert this file, XRD ML file, into DAT file. So we have a software here, Powdell converter. So what we have to do, we have to simply go there, install it, do browse, and because it is in desktop, choose your XRDML file. Okay, now XRDML, then BaTiO has been come here, open. Then in which you want to convert this file, you want to convert it that file, then again do browse and here choose that file. Now save it. Okay, here write BaTiO. Now save it. So now your XRDML file has been converted into that file, and then load values from source. Now you can see that your minimum angle of XRDML is 10.001 and your maximum value of angle 2 theta equals to 79.996, and we have taken our data in step size of 0.008, and because we have used copper source for XRD, so our wavelength of XRD is 1.540598 and the second wavelength is 1.544426, and if you take the wavelength ratio, then it is 0.5000, and here intensity pattern we have got here. Now convert it. Okay, conversion was successful. Okay, now cut it. Our first step has been done there. Now check, have you got that file? Yeah, we have got that file here. Now you can see that your data is very good. You have minimum angle, you have step size, you have maximum angle, or now you get intensity pattern here only. So what we have to do, our second round is delete these all things above the angle portion. Okay, now we have delete this time and add extra. Okay, now file and save. Now cut it. Okay, now move in our third round. What we have to do now? We have to create a background data point. And don't assume that background data point means any information about background in XRD pattern. No. Actually, it is property of our sample which we have put there. It is very interesting to know that have you seen any coin as sample holder in XRD lab? This coin cost is 1,30,000. Why it is so costly? Because it made in such a way that that condition never satisfied there. So background means not any diffraction pattern due to coin and means sample holder. Background means it is a property of our sample also. So for finding background peak, what we have to do, at first go to foolproof software. Now go to wind plotter. Here click this icon, because we are doing our calculation in freeform it. So click here, freeform it, then OK. Now because we want to background of BaTiO, click on BaTiO. Now open. Now what we have to do? Point selection. Now do automatic background. What we have to do? Noisy data. Okay. Now you can see that this is our background points, and now we have find this noisy data of background. Okay. Now cut it. Point selection. Background point. Yes. Where our file is also available. So Rietveld refinement BaTiO. Okay, file name is BaTiO. What we have to do? Slash background, then dot bgr, because this is file is under bgr. Now save. Has been created. It contains 93 background points. Okay. Now our second process has been completed. Now go in this file. Now you can see that BaTiO background has been saved as bgr file. Now click it. So you can see that your background has been created here. Okay, now our second process has been completed. After completing our two round, first round we have converted XRDML file into DAT file, and second one is we have created a background file. Now we are going to convert CIF file to PCR file. So what is CIF file? Actually CIF file is a standard data point which has given to us, in which we can find the latest parameter of our BaTiO, and then we can compare these data points with our XRD pattern. So what we have to do, at first we have to go to Google Chrome. So there is a site, crystallographic open database. Now click here. So what we have to do, we have to go in search. Now what we have to do, 1 to 8 element, fill name of your compound, barium. Now our second compound is titanium element, and third is oxygen. Because we have 3 element, so what we will put here, number of distinct element, minimum and maximum, put 3 here, and also put 3 here. Now send. So you got so many files here. Now see what you want. Actually we want P4mm file, because space group or of BaTiO is P4mm, and we want CIF file. Now download it. It is downloading here. Okay, now go in file, save as, where we have to save, where our data is available. Move in desktop, and Rietveld refinement of BaTiO. Okay, now give it name BCTO. Okay, now save it. Now our third process has been completed. But one thing I want to give a suggestion to you all. For this, for reading CIF file, we want Vesta software here. Without this you can't read CIF file. So please download Vesta Win64 software here for reading CIF file. Otherwise your system can't read this. Okay, now our file has been saved here. You can see that BaTiO, BaTiO CIF, two kind of files we have saved here. Now what is our fourth process? Now go to Foolproof software, move in EDPCR. Now CIF, so move in desktop, it will refinement BaTiO. Now put it here, BaTiO CIF. Now open it. Open it. Now you can see that all values has been put it here. Now it is X-ray. Okay. Now do okay. Now our CI file has been converted to PCR. Then what we have to do? Move in general. X-ray title. Give title BTO. Then refinement calculated a powder diffraction profile because we have done XRD of powder. Then do OK. Now move in pattern. So we have added one file here, data file peak shape. Now at first we have to go data file. Here upload your file. Browse. As we know that we have to put here DAT file of our XRD. Open. Now we are doing pre-format programming here because we have given initial angle, final angle and step size here. Now go to refinement simulation because we are doing X-ray here. Now move in pattern calculation. We will do Thomson Cox pseudo void programming here where angle is 2 theta and theta minimum is you can see in your data 10.001 minimum 2 theta we have taken in XRD and 79.996 is our maximum angle and the step size we have taken 0.008. Now do OK. Now select a background type. So we are doing linear interpolation between a set background point and a refined height. Do OK. Now do OK. Now give phase. So name of phase. What is name of phase? I have given you phase name in a CI file P4MM. Actually first letter will be capital and second one and last one is a small letter. Space should be given there. Structural model. It was Rietveld method. We are doing Rietveld method. Okay. Now contribution to pattern. We are doing X-ray and a peak shape. What we have done here? Yeah, Thomson Cox pseudo void. Automatically generate from space group. Okay. Now move in symmetry. P4MM space group has been taken. It is now symmetry operation automatic. Now values has been come here. Do OK. Now do OK. Now move our most important topic, refinement. So what we have to do? We have to move in profile. So you can see that by CIF file it has been taken already value of A, B, C, alpha, beta and gamma. Okay. Now do OK here. Now move in background because we have created a background file. Import from background file. So BTO background. Now open. You can see that all data point has been taken here. Now do OK. Now do OK here. Now save the file here bto dot pcr because our final file will be PCR file. Now save it.
After running the program, this is our refinement data which we have to refine, and this is our actual data.